Yeah, it's a halftime.
All right. We got 2 more lessons this week. These will be our last 2 lessons of the semester, 6-5 and 6-6. Wednesday is review day, and Thursday is test over chapter 6. And then next week we'll be getting ready for the finals. Your guys' final will be next Thursday. 1, 2, 3, 4 on Thursday, 5, 6, 7 on Friday. We also, Friday what we'll do is we kind of have an extra day built in because you won't have as much time to correct and retake. We'll have like an activity that day. We probably won't start reviewing for the finals quite yet. But what we'll do is give you an opportunity to correct your chapter 6 test if you want to. You can do that. And then next week we'll start reviewing. The way the reviews are set up, we're going to do 2 chapters a day. So we'll do chapters 1 and 2, we'll do chapters 3 and 4, and then we'll do chapters 5 and 6. Kind of going over everything that we've covered since the beginning of the year. Okay. Today, I would say that today's lesson is kind of straightforward for the most part. A little bit of common sense kind of things, which is good. But what we're going to talk about is inequalities in a triangle today. And when we talk about that, we're talking about comparison of angles and sides. Like we're going to say that this side is longer than this side, or this angle is longer than, or bigger than this angle, or smaller, or whatever. And we know that based off of information that we're given. And we may not be able to always find all 3 pieces, but we can still write a comparison, and that's why we're going to use an inequality. Okay? And so that's why this is called inequalities in triangles. Basically, here's what we know. If we have a triangle, and in this triangle, what kind of triangle do we have on the left up here? It looks obtuse, right? It looks like this angle is bigger than 90, okay? And we can only have one obtuse angle in a triangle if we have a triangle. The other 2 angles would be acute. So this is the largest angle. These other 2 would be acute angles. And so the side across from that obtuse angle will be the longest side. Based on how that triangle opens up and the sides that are formed, this would have to be the longest side. So the largest angle is always opposite the longest side and vice versa. Okay? So if I know one, I know the other. The other thing that would be true, if I tell you that this is the smallest angle, the side across from it would be the shortest side, the smallest side in that triangle. Okay? And the same could be said for like the medium side. The medium angle and the medium side would all be across from one another as well. So the theorem, I think, is kind of a funny name of the theorem, the triangle longer side theorem, right? It's just pretty much telling you exactly what's going on. If 8 is longer than 5, if this side is longer than this side, AB is bigger than BC, so that's a true statement. Therefore, if this is longer than this, the angle across from 8, angle C, is bigger than the angle across from 5, which is A. So we know C must be bigger than A. We don't know the actual measure of C and A, but we know they're bigger. Okay, we know C is bigger than A. I could also say angle A is less than angle C. So I could write that inequality a couple of different ways. The same goes true down here. We don't necessarily have to know all 3 angles or all 3 sides. I can compare the 2 based off what I'm given. So right now, I know that angle A is bigger than angle C. 50 is bigger than 30. So the side across from A, BC, is bigger than the side across from 30, which is AB. Okay? And so I know based on the angles that I'm given, those 2 sides I can write a comparison of. We use an inequality. Okay. If I know 2 angles in a triangle, can I find the third? Yeah. Yes. Okay. What would I do to find angle F here? We know that this triangle has a sum of 180. If I'm given the sides, I may not be able to find the third side. But if I know angles, I know that the triangle has to add up to be 180 on the inside. I know two of them. So I'm going to take 180 minus 51 minus 47. Okay? And what's that leave me with? 82. So if I put these angles in order from smallest to largest, the smallest angle would be angle E, and then angle D, and then angle F. But we want to put the sides in order from shortest to longest. So because we know the angles, what side would be across from angle E? Well, here's angle E, so we're going across the one that does not touch it, and that would be DF. So DF is the shortest. The middle one would be EF, and the longest one would be DE. And remember, those can be written in any order. DE and ED are the same thing, okay? And so how you write that doesn't necessarily matter, but we have to make sure and one thing you'll have to pay attention to is directions. Are we going shortest to longest, longest to shortest? We could go either direction today. Okay, this one here does not have the triangle drawn out necessarily. So what I'm going to do is I'm going to draw a triangle right next to it here. This archaeologist has 3 different locations where they found some types of artifacts. And there's some pottery, there's some tools, and there's some drawings. Okay, so those are the 3 spots, and they form a triangle. And then it goes on to tell me, so here, when it says 82 meters away, the pottery is 82 meters away from the tools. We're talking about the length of a side. We're not talking about angle measures here. Okay, so we're saying that this is 82 meters. We also know the pottery is 89 meters away from the drawings. Okay, the tools and drawings are 96 meters apart. So we now know the 3 sides, okay, and we're trying to use the 3 sides to find the 3 angles. We're going to list the angles from smallest to largest. Okay, so what's the smallest side? PT, right? 82 meters is the shortest side. So what angle would be across from that? Angle D. Okay, 89 is the next side. Across from 89 would be angle T. And then finally, 96 is the biggest, and across from 96 would be angle P. Okay. So the good thing is not a lot of work involved here, right? It's just a matter of being able to look at the triangle and identify the different pieces. Are we able to actually find what the measure of those angles are? No, but we don't necessarily care. We're just writing a comparison. Okay. Okay, these 2 are both pretty easy as well. They give me the 3 sides. We're just going to identify the 3 angles, going in order from smallest to largest. So we're going to go with the smallest side first, which is 5.9. Across from 5.9 would be angle Q. And then 6.1, across from 6.1 would be angle P. Across from 6.8 would be angle R. If I give you the angles, and here we know all 3 angles, so this is even easier than the one we did a few minutes ago. Smallest to largest, across from 29 would be ST. Across from 30 would be SR. And then the largest one is opposite the 121, which is RT. That's all there is to it. Okay, all this question is asking is, how do we know which one is the largest? Well, or the longest side. The longest side is always opposite largest angle. the shortest side is opposite the smallest angle. That's everything that we're talking about in that triangle inequality theorem, just comparing sides and angles. All right, this next one I think is kind of a tricky problem. We've got two triangles side by side, and we want to put all of the angles in this picture in order from the smallest to the largest. So how many total angles do we have here that we have to identify? 6, right? We got 3 triangles. We've got 3 angles in each triangle. We got 2 triangles. So we're going to go 1, 2. We're going to go from small to large. Smallest to large. We're going to list out these 6 in order from the smallest to the largest. Now, before we do anything else, what I think would probably be the best to do is look at each triangle individually, okay? If I look at this triangle over here on the left, 10, 6, and 12 are my 3 sides. Because 12 is the longest side, that means angle A would be the biggest angle in this triangle. And then this would be the medium, and this would be the small. I'm just going to put BMS, big, medium, and small. Okay, on the right side, the triangle on the right, 14 is the longest side. So this is my biggest angle. And then this would be medium, and this would be small. Okay. The most important part of this whole statement right here is this right here, okay? And we only know this because they tell us this. BD bisects ABC. So we know BD is going to come down here, and what does it mean to bisect? Half of it, right? It's going to split it in half. So we know these two are equal. Do we know the same up here? Are these two going to be equal then as well? Not necessarily. Okay, so just because these two are congruent doesn't necessarily mean these two are congruent. These are the only ones that are given to us, so we know those two are the same. Okay? Now, here's the first thing we're going to start with. These two angles are the same. This is the medium-sized angle. This is the big angle on this triangle, right? So what has to be the biggest angle in this whole picture? Angle A. Yep. The largest angle in this whole thing is angle A. And I can just use a single letter to name it. It's this one. Because we know this one is bigger than this, and these two are the same. Right? This is the biggest, this is the medium, but we know these two are the same.
Oh, it's by circle. I was like, how is 12 greater than 14? But it's not 14, it's 7. Right?
Do what now?
Is D angle B, is it 7?
Is it 7?
How many options? No, I don't.
So we don't actually know the angle.
Yeah, I don't know it. I'm taking the outside and trying to put it into the.
Yeah, so we can't actually find the angle. But the only thing we do know is these two are the same, whatever that is. Okay? But with these two being the same, we know that this one is smaller than this one. This one is bigger than these two. Okay, but these two are the same. So this one has to be bigger than both of these. Does that make sense? Okay. All right, so then the next thing that I'm going to do is these two are the same. So I know I said let's put them in order from smallest to largest. These two are the next two biggest, okay? Because we know this one's bigger than these two, and we know this one's bigger than this, okay? So these two are the same, whatever that is, and so those would be the next two that we're going to list out. And I'm going to put both of those here. And it doesn't matter which one goes where. The only difference here is we have to use 3 letters to name this one. So I'm going to say angle ADB and angle CDB. Those two can be interchangeable because they are the same measure. Whatever that measure is. We just don't know what it is. Okay, so we definitely know A is the biggest. We know these two are the same, and they're bigger than these 3. What is the very smallest angle that we're going to have? ABD, how come?
Because it's like, the smallest side, I think.
Yeah, and we don't, right, okay, so we know that 14 ends up being the smallest, or the biggest side in all the pictures, but because this triangle has the biggest angle, it's also gonna have the smallest angle, right? Because let's say that this is 40 and 40, and let's say this is 100, then maybe this is 40, okay? But we know this is bigger than anything over here, okay? So these two are not the same, but because this triangle has the biggest angle, it's also going to have the smallest angle as well. So this guy right here is going to be the smallest out of the whole thing. Okay, the only 2 angles then we have left are these 2 right here. And that's pretty easy to determine, right? Because which one's going to be bigger? Yeah, C, right? So C is going to go here. And then angle CBD would go here. Okay. So it's kind of a tricky problem, okay? We're just looking at relationships and seeing, don't always go off of, oh, this is the longest side, so this one has to be the biggest angle out of everything, because it doesn't necessarily work like that. Okay, I'm going to kind of show you an example. Basically, what we're looking at here is the 2 smallest sides, 2 and 4, must be bigger than the biggest side. So when I add the 2 smaller sides together, they have to be bigger than the biggest. 2 plus 4 is 6. 6 is bigger than 5, so we would say yes. We could make a triangle. Okay? This one's pretty straightforward. We've got sides of 2 and 2. If I were to move this up and down, and that's what this little arc is right here, and I put it over here, because these 2 have the endpoints at the end of 5, are these 2 ever going to touch one another? They're never going to hit, right? They will not form a triangle. So does 2 plus 2 give me a number bigger than 5? My answer is no. 4 is not bigger than 5. Okay, the one that's a little bit tricky is, it looks like these 2 will eventually meet, but they get really close, but they don't quite get there, okay? Because 3 and 2 must be bigger than 5. So it's going to get really, really close. But if it's not bigger than 5, if it's not bigger than the biggest, it will not make a triangle. Okay, Sophia?
Why do the arching lines literally touch, but like it's in some?
Looks like they touch, but they don't really touch.
Really?
Yeah.
Because it's just like.
Yeah, I know. And it does look like they touch. Yeah.
Like I get the math behind it, I don't
Yeah.
know, I just feel like that's the same.
If we were to measure it exactly, right, they would come right up next to each other, but they would just barely miss one another. Okay. All right, so I give you 3 measurements, and what you got to make sure of is make sure that you add the 2 smaller ones, right? Because I know that 10 plus 9 is bigger than 4, and I know that 4 plus 10 is bigger than 9. But is 4 plus 9 bigger than 10? So make sure the 2 that you add together are the 2 smaller ones. And they have to add up to be bigger than the big one. Okay, and 13 is bigger than 10, so we would say yes, this would make a triangle. Okay, here 8 plus 9. Is 8 plus 9 bigger than 18? No. 17 is not bigger than 18, so they do not form a triangle. And then the last one is 5 plus 7 bigger than 12? No. It's going to be really close, and that's kind of like what Sophia was asking. It's going to almost look like they're going to get there, but they're not going to quite get there. Okay. Then we would have something here. If I were to give you 3 lengths, let's say I have a segment of 2 inches, another one that's 3 inches, and then one that's 7 inches long. And if I ask you to make a triangle with these 3 segments, okay? Maybe it's like a little piece of spaghetti, and I want you to like put them together to make out a triangle. Well, if I do 2 and 3, then we could do something like this, but 7 is going to be too long. Okay, I could also do something like this, but I need it to form a triangle. Okay, so if I have lengths of 2 and 3, there's no way, if the third side is 7, that I can form a triangle that meets at a point. Well, there's a way that we can determine that without having to make a triangle out of it or look at the pieces of it and try to see if we can put it all together. One that would look like this. And then this side has to form a triangle. We don't want it to be longer. We want this point to be this point. Okay. The last group of problems we're going to talk about here is a triangle has 2 sides of 14 and 9. I want to figure out what would be possible lengths for that third side. Okay? And there's more than just one answer here. There's a lot of different answers. So we're going to write our answer here as an inequality. Okay? So first thing, what would be the lowest possible value that I could have? Colton?
5.
Okay, would 5 work?
6.
Okay, 6. What about 5.5? Darn decimals, right? So it doesn't, and I know we always think of whole numbers, so 6 would definitely work. Anything bigger than 5 would work. So even if it's just slightly bigger than 5, then we could do it, right? And so one thing I could do here is I could take 14 minus 9. And if you wanted to see, if I draw out an example here, this would be 9, this would be 14, and then maybe this could not be 5 though, so let me put x in here. X must be bigger than 5. Okay, how large can we go? Would like 15 work?
No.
Well, is it okay if it goes too far out? As long as it's still.
So how wide can we go? How long can we go? That third piece.
Would it be like 23?
Okay, would 23 work?
That'd be equal.
That'd be equal, okay. So what would we have to say? Less than 23, okay. So if I did one look like this, here's 14, here's 9, and this would be x. So this time it's the longer piece, right? It's a longer piece. To figure out how long that longer piece could be, we add those two together, and we would say x has to be less than 23. Because it can't equal 23, right? Because 14 plus 9 equal 23. But could it be 22.5? Yeah, it could be something just barely less than 23. So we got to keep decimals in the mix here. Now, there's two different ways to write your answer here. And I'm okay with either one, but what I'm going to show you here is compound inequalities, especially compound inequalities with the word and, are typically written in a little bit different fashion. So the way that I will show you this, and you might remember this from Algebra 1, okay? X has to be somewhere between what two numbers? Now, I changed the symbol around here, but what we're saying is that X must be between 5 and 23. And this is the way we're going to see our compound inequality written a lot of times. This means X is bigger than 5. This means X is less than 23. We don't have to put the word and in here. Both of those are the same thing. They both mean the same thing. Either one of those would be correct. But I think on big ideas, they're going to write it like this. And so we just need to be familiar with that and what it means. Okay, and I think we've seen that before. All right, so if I do this last one here, what's the low end going to be? Okay, 20 minus 12. Has to be bigger than 8. Okay, what's the high end going to be? Oops, 20 and 12, which is 32. So it has to be somewhere less than 32. So 8 has to be somewhere between 8 and 32. So are there a lot of possibilities? Yeah, we don't want to list them all out, right? Writing the inequality is a whole lot better. Because we think of nice whole numbers, 9, 10, 11, 12, all of those would work, all the way up to 31, but we could also have decimals and fractions in there as well. And that would throw in a ton of possibilities. That would work. All right.